Question number 27 deals with the capacitance. Means ability to store charge. Like for a water tank, it has the ability to store water, liquid. Similarly, a capacitor is an arrangement where you can store electric charge. The value of electric charge which you can store, that value is small. That is why even today electricity cannot be stored in large volumes. If you can store electricity, then it will solve a big problem. Anyone? How? Yes? Electric vehicles, yes. If you can store electricity, then you can use electric vehicles. At present, that is a battery. Battery uses electricity in the form of, first in form of a chemical energy. That chemical is changed to electrical. If by some mechanism, some method, you can store, we can at present also store, but that value comes out to be very small. During the chapter, during different numericals, you will see this device is a capacitor. It's a small device. It can store very small amount of energy. Capacitance is of the order of microfarad, voltage, even if you apply 100 volt. Energy stored is very small, of the order of 0.01 joule. But it can be used in electronic circuits, but not for regular domestic or commercial applications like running a fan or something. So, what is a capacitor? Capacitor, simple way of doing it is take two plates. If you take two plates, connect it across a battery, the terminal which is connected with the positive terminal will acquire positive charge, and the one which is connected with the negative terminal will acquire negative charge. So, electric field exists between the plates from positive to negative. Suppose the charge is Q. If there is no voltage applied, if the value of voltage is 0, charge stored is also 0. If this voltage increases, this charge also increases. So, Q is proportional to what? Q is proportional to voltage. This constant of proportionality is termed as capacitance. C is equal to Q by V. Means what? Capacitance is charge stored per unit voltage. Voltage V across a capacitor can create charge Q on plates. If voltage across plates increases, charge also increases. Q is proportional to V, Q is equal to CV, C is equal to Q by V. C is termed as capacitance. SI unit, yes, SI unit, yes, is farad. 1 farad means what? 1 coulomb divided by 1 volt. Dimensions. Dimensions of capacitance. Capacitance is equal to charge divided by voltage. Charge, yes, SI unit, A into T, because ampere is fundamental. A into T, current is fundamental. Voltage, work done. Work done per unit charge is equal to what? Yes, M minus 1, L minus 2, T, yes, T is power 1, T is power 1, it is T is power 2, minus 2 if you take a numerator, it is 4, T is power 4, A 3 minutes with you to write. B part deals with the capacitance of sphere. If we have a sphere, if there is no charge, there is no potential. If you put up some charge, say +1, suppose it is +1 volt, 2 volt, 3 coulomb, 3 volt. Suppose you have a charge Q. The radius of the sphere is R. We want to find out capacitance of the sphere. And we want to prove it is equal to 4 pi epsilon R. This is what the objective is. Notes बंद कर दो. Draw the diagram. Previous chapter. What about potential? If a sphere is having charge Q, radius is R, what is the potential on the surface of the sphere? Potential is Q by 4 pi epsilon R, covered in previous questions. In chapter 1D, all questions, all derivations, we need to cover whatever you have done in first 26 questions. All questions you will take one more step, charge divided by voltage. What about Q by V? 4 pi epsilon R. Definition, capacitance is charge per unit voltage. So capacitance of sphere is what? 4 pi epsilon R. Competition question as an example. Capacitance of earth. Earth is a sphere. So capacitance of earth, which is a sphere, is equal to 4 pi epsilon R. What is the radius of earth? 6400 kilometers. R is known, 6400 kilometers. SI unit is meters. 1 by 4 pi epsilon naught is equal to what? 9 into 10 per 9. So 4 pi epsilon naught is equal to 9 into 10 per 9. Calculate. Time with you is 3 minutes. 3 minutes to write. First you will get answer in farad, then you write in microfarad. approximately 714 into 10 raised to power minus 6 farad. That is 714 microfarad. Capacitance of sphere 714 microfarad. Refer to numericals. Refer to book. Page 1 by 161. Numerical number 2. Numerical is when electrons equal to Avogadro's number are transferred from one conductor to another, a potential difference of 10 to the power 6 volt appears between them. Calculate the capacity of the system of two conductors. 2 minutes with you to write what is given, what is required. How many electrons? Avogadro number. So write what is charge. Given is charge. How many electrons? Avogadro number 6.023 into 10 to the power 23 electrons. What is charge on one electron? 1.6 into 10 to the power minus 19 coulomb. Given. How much voltage is developed? 10 to the power 6 volts. You have to find out what? Capacitance. Concept. If charge is Q and the voltage is V, then capacitance is equal to what? Charge per unit voltage. Charge is given to you. You can write approximately 6 into 10 to the power 23, 1.6 into 10 to the power minus 19 divided by voltage 10 to the power 6. Units, farad, capital F. 9.6 into 10 raised to the power minus 2. Numerical number 1. Numerical is 27 drops of same size are charged at 220 volt each. They coalesce, that means combine. They coalesce to form a bigger drop. Calculate the potential of bigger drop. Given is how many drops? 27. And let n is equal to 27. 1, 2, 3. How many? 27. And now it is a big drop. One big drop. Each was having voltage small v. How much? 220? 220 volts. You have to find out what? Yes? You have to find out what? Potential of big drop. Let it be capital V. Two minutes with you to try. Hint. Let the charge on small b small q and radius be small r. Big drop. Let the total charge be capital Q and radius be capital R. Next hint. What is the potential of small v is equal to small q over 4 pi epsilon naught small r. Potential, if a sphere is charged with charge q, radius is r, potential is how much? Q by 4 pi epsilon naught r. For this one, capital V is equal to capital Q over 4 pi epsilon naught r. So, you can write like this. Step 1, V is equal to Q by 4 pi epsilon naught r. Step 2, capital V is equal to capital Q over 4 pi epsilon naught capital R. Step 3, divide one by the other, 2 by 1. Say this is equation number 1, this is equation number 2. Divide equation number 2 by 1. Capital V by small v is equal to what? Yes. Yes. Q by R over Q by R is equal to capital Q by small q, capital R by small r. That means basically you have to find out this capital Q is how many times small q. Suppose there is 1 coulomb charge, 1 coulomb, there are total 27. So total charge will be 27 coulomb. Law of conservation of charge. That is why capital Q is equal to what? 27 times small q. 1. What about radius? Total volume remains the same. Volume of all these, that is 27 times volume of 1, 4 by 3 pi r cube is equal to volume of big drop. Total mass. Suppose each drop is 1 gram. Big drop will be 27 grams. Each drop is 1 milliliter. Total big drop will be 27. So, it is 27 times r cube is equal to capital R cube. Means what? 3r is equal to. So, put a value here. Capital Q is how many times? Capital Q is how many times? 27 times. Capital R is how many times small r? 3 times. What you get is 9. Voltage of big drop, capital V, is equal to 9 times small v. What is the voltage of small drop? 220.